welcome. Today we would be talking about the K-maps or the Karnaugh maps. And Karnaugh maps are used to reduce any given function. For two inputs, here we are representing x along the vertical axis and y along the horizontal axis. So this first square is 0, 0. This is 0, 1. So 1, 0 and 1, 1. Hence, out of this combination, first 0 is representing x and second is representing y. So if I want to represent the function here, let's call it f1. So it would be x dash y dash. And this function f2 would be equal to xy. In fact, Karnaugh map can be used to represent the other functions. Now let's talk about the different gates. So we have AND, OR, XOR, and XNOR. And for AND gate, we know that both the inputs should be equal to 1. So this is in fact our AND gate. So it would be F is equal to F and let's call it equal to XY. For OR gate, either of our input should be equal to 1. So F OR would be X dash Y, XY dash plus XY. Similarly, for the XOR, the input should be dissimilar. So these two squares would be representing X OR. So in fact, it would be X dash Y plus XY dash. And finally, for XNOR, our inputs should be similar. So F NOR is equal to X dash Y dash plus XY. As I did mention earlier that this Karnaugh map could be used to reduce the function. So now let's reduce them, and as a selection, let's use this OR functionality as an example. So we would be reducing using Karnaugh map, and let's also reduce using the Boolean algebra. So our F OR is equal to X dash Y plus XY dash plus XY. Now, first of all, represent this function inside the K-map. So as presented earlier, so this is our representation. Now create the groups out of this matrix in a way that ones are combined together and they must be either connected in the horizontal direction or in the vertical direction. So these two ones could be combined together. Similarly, these two ones could be combined together. This could represent our G1. This would be our G2. Hence, our FR would be composed of G1 and G2. Here I must mention that you should combine the ones either in pairs or multiple of the pairs. So these two ones are combined together. However, we cannot combine all of these three together. Moreover, the ones are combined either in horizontal or vertical direction, and there is no combination in the along the diagonal. Okay? So now for G1, only write the input variable which is not changing and discard any other. So here x1 is being kept constant along this group along the horizontal direction, but y is changing. So this would be x here plus for G2, y is constant, but x is changing value, so it would be y there. Now let's reduce the same function using the Boolean algebra. So I have written for the OR function. Now using the Boolean postulate, combine the terms which has at least one input common. So we could combine here y, so we could combine x actually here. So x are taken as a common and we are left with y plus y dash. We know that y plus y dash is equal to 1 for Boolean algebra. Even if you insert 0 here, then 0 complement would be equal to 1, or if and vice versa. So we are left with xy dash plus x. Okay. Now I would be using the postulate 4 of the Boolean algebra, which is about the distributive rule, and I would be using the b part of it. So hence this equation could be written as x dash plus x into y plus x. As above, it would be 1 dot y plus x, and now we have y plus x here, or x plus y. Similarly, as we had from the Karnaugh map. So we have reduced the or from x dash y plus xy dash plus xy to x plus y using K-map as well as the Boolean algebra. Thank you very much.